Good afternoon, ladies and gentlemen. This is Mr. Holmes getting ready to talk to you all about how to divide rational expressions. All right. Now, as you should have already learned by now, that a rational expression is simply a fraction whose numerator and denominator are non-zero polynomials. I know y'all right now saying like, "Oh, okay, here we go, thinking and talking math." I don't know all of that terminology, so let me break it down for you. Here we have a simple fraction, 7 over 2 divided by 8 over 5. You were taught back in elementary school that when you are dividing fractions, we use the keep, change method. The keep, change method. That means you would keep your first fraction exactly the same, 7 over 2. You would change your division into multiplication. We no longer put the x, but we put the dot there in space. And we would change our fraction 8 over 5 to 5 over 8. In other words, we would take the reciprocal of 8 over 5, which is 5 over 8. And you will multiply straight across, numerator times numerator and denominator times denominator. So when I multiply numerator times numerator, I'll get 35. When I multiply denominator times denominator, I will simply get 16. This is the concept of how to divide rational expressions. All right, we're going to take two polynomials and we're going to divide them. But in order to divide it, we must keep the first fraction the same, change the operation from division into multiplication, and we're going to take that second fraction and take the reciprocal of it. There'll be a little bit more added on to it than this. This is just simple, basic dividing fractions. All right, but the concept, for the most part, is exactly the same. So let's get into it, shall we? Here's what I'm going to do. I'm going to go over an example that I have here, and I want you guys to try to grab this concept, not necessarily the problem. So here's the concept. I'm going to give you guys a question such as 7x divided by 2x minus 10. We're going to take this here and we're going to divide this fraction by another fraction. In this case here, I'll have my x squared minus 6x over x squared minus 11x plus 30. All right. Now, we're going to take these two fractions and we're going to do the keep, change method just like we was taught, back in elementary school, where we keep the first fraction exactly the same. We're going to change this division into multiplication and we're going to change our second fraction. In other words, we'll take the reciprocal. So let me show you what I'm talking about in red ink. Every step that I'll do, I'll try to change colors. So here's my problem. So my first step that I would do is I would keep my first fraction exactly the same. In this case here, I have my 7x over 2x minus 10. Exactly the same. I'm going to take this division and I'm going to turn it into multiplication. And I'm going to take the reciprocal of my second fraction. I'm going to change the order. All right. So x squared minus 6x would go on the bottom. And x squared minus 11x plus 30 would go on the top. From here, we're going to factor and multiply. We're going to factor and multiply. Now, if you've forgotten how to factor binomials and trinomials, then maybe you should look at my video on how to factor. Mr. Holmes, how to factor polynomials. And I will explain how to factor multiple types of polynomials. So here we have a monomial, not much that we can do about it here. So we're gonna go ahead and I'm gonna keep my 7x exactly the same. There's nothing I can do here. 7x over, I notice here I have a binomial. Binomial means two terms. I have two terms here that I can look to see if I can find a common factor. I want to take out the GCF if possible, greatest common factor. Here the greatest common factor between 2x and negative 10 is 2. 2 is the largest number that I can divide into both 2x and negative 10 evenly. When I factor out 2, I'm going to take the same 2 that I factor out and I'm going to divide each one of these by 2. So 2x divided by 2 leaves me with x. Bring down my minus sign. 10 divided by 2 gives me 5. This is how you factor, guys. Times. Here on this side, I'm dealing with a trinomial. Trinomial means the prefix, tri means 3. I'm dealing with 3 terms here, 3 nomials. To factor, if possible, since the value of a, the coefficient of x squared, in other words, is 1, I will open up 2 sets of parentheses right now. In each set of parentheses, I will put an x. I have 2 of them, so I'll put x in both sets of parentheses. From here, I will find 2 numbers that multiply to give me a positive 30, but those same 2 numbers, or factors should I say, will add to give me negative 11. Again, 2 numbers that multiply to give you positive 30, but when you add those same 2 factors, you get a negative 11. Now I know what you're thinking, well, 10 and 3. Well, if we was to add 10 and 3, we would get 13, not 11. Same thing if they're both with negative, we'll get a negative 13. However, if we use a negative 5 and a negative 6, both these will add to give you a positive 30, multiply to give you a positive 30, but also add to give you a negative 11. This is how you factor a trinomial. Here we again 2 terms. At the bottom we have a binomial. All right, in our in our denominator it's a binomial. Because it's a binomial, we would look for common factors, the GCF, between x squared and negative 6x. Clearly they both have an x in it, so we're going to divide out, and we're going to factor out an x. When I factor out an x, I'll divide each one of these by x, and I'll be left with x minus 6. This is how I get my new rational function. From here, I will look for common factors. Clearly, I have x minus 6 in the numerator and denominator, so both of those will divide into each other evenly. Here I have an x minus 5 and an x minus 5. Therefore, both of these will divide each other evenly. Here I have an x, here I have an x. That's outside of the parentheses. Clearly, they both will divide each other evenly. The only thing that I am left with in this case is simply a 7 divided by 2. As part of my final answer. Notice I put emphasis on the word part, because to get the remaining part of our answer, we need to take every quotient that we divided by. Every time that we divided by. In this case here, we divided by the expression x minus 5, because x minus 5 went into itself. We divided by x, because x went into itself. And we divided by x minus 6, because x minus 6 went into itself. This is how we will get the remaining part of our answer. So part of our answer right now is 7 over 2. So I want to take each one of these and set them equal to 0 and solve them for x. So I'm going to take my x minus 5 I'm going to set it equal to 0, and I'll solve this for x. In this case here, x cannot be equal to. I'm going to move this negative 5 over to the other side of the equal sign, and I'm going to change its sign from a negative to a positive 5. That tells me that x cannot be equal to 5, because if it did, then 5 minus 5 will make this 0, and we cannot have 0 in our denominator. The next thing I would take is this x that I scratched out. I'm going to take that x, I'm going to set it equal to 0 as well and solve. Because there's nothing to solve here, this is said to be completed. X minus 4 equals, x is equal to 0. And lastly, I'll take my x minus 6, and I will set this one equal to 0 as well. This is another factor that we divided by. In this case, I'll move this negative 6 to the other side and change its sign. So I'll have x is equal to a positive 6. From here, guys, we are done. We have found all parts of this answer. We found that x cannot be equal to 6. X cannot be equal to 0. And x cannot be equal to positive 5. If it did, with any one of these, our denominator will be 0. And we will have to try to divide by 0, which is kind of impossible. So there you have it, guys. This is how to divide rational expressions. All right, we started off with 7x divided by 2x minus 10 divided by x squared minus 6x all over x squared minus 11x plus 30. We did the keep, change method. We factored all binomials and polynomials. After we done that, we looked for common factors and we divided them evenly. What we divided by, we all set equal to 0, and we solved them. In doing so, we learned what the x variables cannot be equal to. That is just a little quick recap on how to divide rational expressions. This has been Mr. Holmes, and if you know Mr. Holmes, you know what I'll say. I hope you'll enjoy this video. Now have a blessed day.